एथिरे तो ठीक आसुची हला so and good evening everybody. This will be my second webinar on this series, Bharat Heritage series. I actually started it about 6 months ago on the.
Sir, will you please use a earphone or something? The voice is not very clear.
Voice clear asuni.
Jaram sir, good evening. Sir,
good evening.
Little voice clear asuni.
How hello?
Sir, maybe you can confirm from others, but Jaram sir to पहले ताको voice सुना जाउची आपमटा टिके background रो
साउ सर भी कहउतले स्लो आसछु
टिके आपण earphone टा यूज करंतु so we can
चेंज करिया चेष्टा करछु देखलो तो काम करू फोन रे लगे फोन रे जो ना ओहो
Inna sir.
ଭଲ ଅଛନ୍ତି ଚରଣ ବାବୁ
ହଁ ଭଲ ଅଛନ୍ତି
ହଁ ଭଲ ଅଛି ଆଉ ବରହମପୁର ନା କୋଉଠି ଆପଣ
ନା ମୁଁ ବରଗଡ଼ ପାଖରେ
ବରଗଡ଼ ପାଖରେ
हेलो एबे वॉइस आछी सर टिके क्लियर हैला कि ना
टिके तथापि माने वॉइस टिके बैकग्राउंड रो असला परि लागुची से वॉइस शार्प नाही so you will miss many of your words actually
हां शार्प नहीं मो तंटी बस जाईची
हां माने एमती तो हमें we can hear but we probably will miss
रोन सर फैन टा बंद करे
हां
फैन बंद कर एबे टिके क्लियर आसला
जरन सर सुन पड़छंदी
हां वॉल्यूम टा टिके स्लो अछि किंतु माने कम सुबुजी टिके कम सुबुजी
वॉल्यूम टा बढ़ाନ୍ତୁ
मैं सुना जाउची कि से वॉइस शार्पनेस जेतु नाही विल
क्लियर
मिस योर वर्ड्स एक्चुअली
ऑडियो देखिलो ऑडियो रे कोन अछि
so the best thing is if you can use a headphone
हेडफोन नहीं परा मोटा खराब हो जाईची जो हेडफोन क्लास रा खराब हो जाईची
हां बटन टी हला बटन
now it is okay
now it's perfect
सेटिंग भूल थिला मोर सर
okay
कंप्यूटर सेटिंग भूल थिला
okay now it's okay हां
ठीक अछि टिके डिले गला हो ठीक अछि आराम करे
Sir, possibly you can slightly talk about what is this Bharat Heritage Series, and then you can start today's talk. You can just give a background of what is this Bharat Heritage Series.
Yes, definitely. Start करिए related. कोई भी होता है Good evening. Uh, I started this Bharat Heritage Series 6 months ago on the eve of our 75th uh, Independence Day, which the Honorable Prime Minister said that we'll have a Swatantrata Ka Amrit Mahotsav. On that occasion, I started this series, particularly keeping in view what was the contribution of India to the world. As you know, many people say the contribution of India to the world is zero, numeric zero, in the ancient days. And in present days, the contribution of India is zero. So that is what people say. Many people say this. To contradict that, I thought that let me start a series. Let me give some webinars in which we can see what was there in the Indian heritage, ancient Indian heritage, which many people may not know. We didn't know this when we were studying in school. Now that I am bedridden, I am passing time reading these things, going through the videos available on contribution of India, and based on that, I have prepared this series. In the past talk, we discussed about the contribution of India to geometry, to gravitational theory, to atomic theory. So those were in very preliminary level, but there were some contributions. Those contributions we discussed in the past talk. Today, we are going to talk about computing. In the Bharat Varsha or in the ancient India, was there some contribution to computing towards computing? We'll try to investigate that in this webinar. And as I have mentioned, this does not require any background in computers or in higher mathematics. Any person who has a school pass out, who is a school pass out, will understand this. Only thing is, there will be some Sanskrit verses. What I will do is, instead of reading out those verses, I will just mention the meaning of those verses so that it will be easier for many people to follow, those who are not acquainted with Sanskrit. So, except that, it should be in the level of a uh, undergraduate student level. In that level, I have tried to make it. It may take about 1 hour or 1 hour to 15 minutes when we start it. Okay, so with that, let me start. Uh, as I told, the contribution of India, people know that it is zero. And Aryabhatta proposed zero. That is what many people think. Now, why that is not exactly correct? That we'll see. Now, when we say 0, 1, 2, 10, or 0, 1, all these are based on some base. What is the base? Look at the English alphabet. There are 26 alphabets. But by arranging these alphabets, taking these alphabets appropriately, we can have innumerable words. So the base is 26. With only 26 alphabets, we can have innumerable words. Similarly, when we come to numerals, in the numerals, ancient system, if you look at ancient systems, Egyptians had 10 base, so 10 numerals. Babylonians had 60 numerals. Mayans had 20 numerals. Ancient Chinese had 10 numerals. So using them, they used to develop their number system. Today, in the present era, the base is either decimal, which is 10 numerals, or binary 2 numerals, octal which is 8 numerals, or hexadecimal which is 16 numerals. Last three are used in computer science or in electronics. These people use these three, binary, octal and hexadecimal, whereas decimal is used by everyone. So don't worry about binary, octal, hexadecimal. You just know that we used numbers on 0 to 9 repeatedly to generate any number in the present era. So this is about the base. We know about the base 10 nowadays. Earlier also, let us see whether we knew about base 10. Now to represent the numbers, we have to use some symbol. So in this shows some of the ancient numerals like hand signs. In Australian Aboriginals, they used hand signs. Minoans numbers is shown, other numbers are shown. Arabic number or Indian number or ancient Indian numbers are 1 to 10, 100, etc. So these are from the ancient numerals. Now using these numbers, when we had first uh, got the use of these numbers. Let us see when we had first used these numbers. Before that, why we require these numbers? These numbers are used for two purposes. One is counting pattern, other is counting concern. Pattern is the numbers will be represented by a set of symbols. Like nowadays we are using 1, 0, 2 up to 9. These are a set of symbols. And these numbers progress linearly. 0, then 1, then 1 plus 1, 2, 2 plus 1, 3. That way it progresses linearly. So this is the pattern of counting. Whereas concern is we have limited number of symbols 0 to 9, but we have unlimited numbers. With limited number of symbols, we have to deal with unlimited numbers present day. Notations are clumsy. If you look at the earlier days, ancient era, not in India, worldwide, if you look at ancient India, ancient days, for example, Roman numerals. If you look at Roman numerals, suppose you want to multiply 50 with 30. That will take about 5 to 6 hours if you use Roman numerals. Just multiplying, simple multiplication, 50 with 30, that will take 5 to 6 hours for you. So this become, because of use of those notations, the operations become clumsy. Arithmetic operation is not true. So those were the concerns in the old days in different parts of the world, not in India. So that is what I want to point out. That was not in India. Next. In India, look at this from the Yajurveda. So Yajurveda is from the Vedic period. So in the Yajurveda, in the Chamaka or 11th Anubhag of the Yajurveda, the shloka, one shloka goes about Eka cha meti sascha. So that I am not reading out, but this means that kindly bless us with numbers 1, 3, 5, 7, 33. So look at those numbers. These are all odd numbers. And the numbers 4, 8, 12, 16, 48. These are all even numbers. So kindly bless us with the numbers, these numbers, for prosperity and happiness. This was a prayer to Lord Shiva. So in those days, in the Vedic days also, people had the knowledge of odd numbers and even numbers, and they are separate. So numbers and their use were known to us in the early days, in the early Vedic days also. This comes from
So,
Yajurveda.
here you meant that the odd numbers would refer to prosperity and the even numbers would refer to happiness. Is it like that?
No, no, no. Both
It's
will
not.
refer to prosperity and
Okay, okay,
happiness.
okay. Okay.
So it is that way. Okay. Next. Now, if you just remember the previous slide, in the previous slide, I gave a shloka, Sanskrit shloka. So these numbers are the mathematics that was embedded in the shloka. The shloka was not containing numeric values, but it was containing words. So in the words, we had the numbers. In the shloka or in the form of a poem, we had these numbers. We were dealing with these numbers in the earlier days. Now let us look at another shloka. This shloka is by Adi Shankaracharya. He says, this shloka says, na punyam, na papam, na saukhyam, na dukkham, na mantro, na tirtham, na veda, na yajaha, aham bhojanam, naiva bhojyam, na bhakta, Chidananda Rupa, Shivoham, Shivoham. So this is a shloka, and if you look at how one is reciting this shloka, like na punyam, na papam, na saukhyam, na dukkham, so there is a particular pattern or there is a rhythm in reciting this shloka, which is the basis of this shloka, basis of construction of this shloka. The pattern or the rhythm in this shloka, Sanskrit shloka, is the basis of this shloka. We will discuss about this in more details later. Now, next. Now, this shloka is in the form of a chanda. The chanda in the old days, that comes from a Chhandas Shastra. So there is a set of rules by which one has to form a chanda. So chanda formation is followed by a set of rules. This set of rules were compiled by Pingala Acharya. So Pingala Acharya was a rishi of ancient India of around 200 to 300 BCE. So he wrote this Chhandas Shastra. Now, what is Chhandas Shastra? Details I will discuss in the next slide. But to be precise, in summary, this is the art of creating a poem by arranging the letters in a rhythmic way. If you remember, those who are of my generation, when we studied Odia in the Odia medium school, we were studying about how to write poems. In the grammar, Odia grammar, we were studying about Chanda, Champu, etc. So those were the grammars or the rules. So this Chanda Shastra in Sanskrit, which was given by Pingala Acharya, it describes those rules. We'll see some of those rules, at least two of those rules today. Next. Now, let me give a detailed view of Chanda Shastra. What is Chanda Shastra? By definition, this is a branch of Vedic studies which deals with the science of poetic meters and the rhythmic structure of Sanskrit poetry. So this is basically what is Chanda Shastra by definition. This is an ancient Indian discipline which provides guidelines for creating and analyzing rhythmic patterns in various forms of literature, including the Vedic hymns, mantras, shlokas, and other poetic compositions. And the focus of this Chanda Shastra is on the construction and arrangement of the syllables of the stresses in the poem and the pauses and to create a specific rhythmic pattern which is called chanda or the meters. If you adhere to these rules, so by adhering to these rules and the principles, poets and composers, they created verses which are pleasing to ear, and since these are pleasing to ear, it is easy to memorize and convey the desired meaning. This Chanda Shastra, it encompasses use of mathematical algorithms. That is what I am going to discuss today. It encompasses use of mathematical algorithms and calculations to determine the possible word combinations which fit into the rhythmic templates. So if when you design a poem, it has to follow a rhythmic template. So a template is to be defined. That template is given by Chanda Shastra, and that template is to be filled up using mathematical algorithms and calculations. We'll see that later. Next. And the study of Chanda Shastra involves understanding various rhythmic templates or metrical patterns which are called chandas that I told you. Finally, this one is important. These chandas, they have specific rules regarding the arrangement of syllables and stresses, and they determine the overall structure and the rhythm of the poetic composition. Some of the examples of chandas are Anushtup Chanda, which many of you may be acquainted with this Vishnu Sahasranama that is written in Anushtup Chanda. It starts with all the verses, they start with Va or Ba. Then Trishtup Chanda, Jagati, and similarly many others. So I am going to discuss mostly this Chanda Shastra throughout this talk today. Now this Chanda Shastra, as I told, was given by Maharshi Pingala or Pingala Acharya. He gave 6 algorithms to design a chanda. The first algorithm is called Prasthara. This algorithm is defined through 3 shlokas, 20, 21, and 22 of the Chanda Shastra. The Chanda Shastra is available. You can Google it in the Google. You can find it. This was in first published in 1874. So it was first published there. This was published by this Ascetic Society in Calcutta, and then it is available in Google, so you can get it. This Prasthara, these 3 algorithms. First algorithm is Dubikov Glow, which means there are 2 types of syllables. We'll see what are those 2 types of syllables. Then the second algorithm, following the first algorithm, the second is Misraucha. Misraucha means mix them themselves, mix these 2 types of syllables among themselves. The third one is in this algorithm, the third point is Pruthagla Misra. Pruthagla Misra means mix them themselves again. If you want to proceed further, mix them themselves again. So that way you can proceed. I will give you one example. From the example, you will understand what is meant by this. Now let me come back to the shloka that I showed you earlier. Na punyang, na papang, na saukhyang, na dukkhang, na mantro, na tirthang, na veda, na saja. Now if you look at this, there are letters which are written in red color. There are letters which are written in green color. The red color take less time to pronounce, whereas the portion in the green color takes longer time to pronounce compared to the one in the red color. So we have short pronunciation. These short pronunciations are called lagu. The syllables which are connected to short pronunciation, those are called lagus. Whereas which are connected to long pronunciation, which takes more time to pronounce, those are called guru. So Dviveka glow means there are 2 types of syllables. One is lagu, other is guru. Lagu takes less time to pronounce, guru takes more time to pronounce. So this is divided into 2 categories. Then the second one, mix them themselves. So what we will do is take lagu and guru. So then on its side put lagu. Then take lagu and guru. These are the 2 available. On this side put guru. Now lagu is on the side of lagu and guru. So lagu gives you lagu. Lagu and guru gives you lagu. Similarly, guru, guru. So by arranging or mixing them in this manner, we get lagu out of 2. Now we have got lagu, guru, lagu, and guru. Now if we go to the next step, mix them themselves again, Pruthagla Misra, then what we will do, and the resultant what we got in the last step, that resultant we will take 2 steps, and those will be added to lagu and guru. So that will give us lagu, guru, lagu, guru. So this way it will give us. So we will get now 8 arrangements out of this. we get 8 elements. So this is the past algorithm. Next. Now if I change this Laghu to 0 and Guru to 1, so then what I am getting? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, which is in the binary system, it is 0 to 7 or 8 numbers. So this is proposed in the 200 to 300 BC by Pingala Acharya. So probably this is the world's oldest written record of binary system. I don't know if it was before this, but to my knowledge, what I have seen up to now, this is the oldest written record for binary system. So we not only gave the decimal system to the world, we also gave the binary system to the world in the form of Chhandas Shashtra. And that was a contribution of India. Now, next. But what we know for binary system, the history of binary system says that Gottfried Leibniz, the German mathematician, he is the inventor of the binary system, or he proposed the binary
Yes, sir.
system. Sir, କୁହନ୍ତୁ.
Yes, sir.
Hello, sir, କୁହନ୍ତୁ.
ଆପଣ ଯୋଉ ଲଘୁ ଗୁରୁ କହିଲେ ଏଇଟା is it they have written 01 at that time or now we are interpreting in that manner?
No, at that time also 01 was there. I'll show you
They have
examples.
also.
I will show you examples of that. As we proceed, we will see the examples of that. 01 example also we'll see. And Laghu Guru was there. Laghu Guru was Chanda.
Laghu Guru means small and 0 and 1. It's example, it's okay. But interpretation and all these things were also there at that time?
Yes, that is what I am going to show you. 01, use of 01 also I am going to show you. Okay. So Gottfried Leibniz, he is the father of binary number system. That is what we have read when we started learning binary number systems or digital number systems. We know this. Now, let me tell you one thing, that he himself, Leibniz himself, acknowledges that the Leibniz series, the Taylor expansion of Leibniz series, this was, I told this in the last lecture also. The Leibniz series was proposed by Madhava earlier, about 300 to 400 years earlier than Leibniz. The Leibniz series was proposed by Madhava. And that is the basis, the Leibniz series is the basis of calculus. For calculus, we say calculus, father of calculus is Leibniz and Newton. But before Leibniz or Newton, at least 200-300 years before them, the difference was difference table, and the expansion of tan theta or tan x in a hyper r tan x. This was proposed by Madhava. So that was the basis of calculus, and Leibniz acknowledges that. But unfortunately, the series is known as Leibniz series, or Leibniz Madhava series, or Gregory series, or Gregory Madhava series, because it is claimed in the West that Leibniz and Gregory, they independently invented those series. Although they acknowledge that Madhava has predicted it much earlier, but they say that they independently invented those series. Therefore, these are named in their name, Leibniz series or Gregory series. Now, come to the next point. Next point is, in the binary number system, Leibniz has not mentioned anything about Pingala. But remember that at those time, in those days, the Indian trading of spice was at its peak with the Europe. So European people, they knew about India, they knew about the knowledge system of India, but we don't know whether I am not claiming that Leibniz knew about Pingala or Pingala's work, but this was there. This spice trade was there between India and Europe when Leibniz during the Leibniz period. So it is possible that the knowledge is transmitted. The transmission of knowledge is also there is a possibility. Although we cannot uh, say it for sure, but it is a possibility definitely. Next. Now let us see the application. First we'll see the application in the Chanda, then we'll go to the application in number systems. That we'll see later. So look at the binary sequence, lagu, lagu, lagu. So for that, we have to construct a word, three-letter word. So sa is lagu, ga is lagu, da is lagu. So sagada. So this is a construction of word. Lagu, lagu, guru. Bharasa, sa is guru. Sa takes more time. And lagu, guru, lagu. Kabata, Masiha, Lagu, Guru, Guru, Siha, they are taking more times to pronounce. So this way you can construct other numbers also. So three-lettered words will be constructed using these applications. So if you have three numbers of letter, then how many words are possible? This also was given by Pingal in a shloka. That shloka I am not mentioning here, but in a shloka he says that the number of word possibilities for a n-letter word is 2 to the power 2 to the power n. I hope Sausar gets some hint about whether they knew about the numbering used was not or not. So 2 to the power n means 3-lettered means 8 words. So if it is 4-letter, then it will be 16. So that way. Next. Now, this knowledge of Chhandas Shastra was extended to combinatorics. We in the early school days, late school days, early college days, we knew about permutation and combinations, which is a part of combinatorics. This is primarily concerned with counting, and using this, we do counting. These are used in statistical physics, evolutionary biology, machine learning, and the list goes on. So these are four of the important areas where combinatorics is used nowadays. Now, in those days, whether it was existing or not, let us see that next. So let us see one example of combinatorics. This is for particularly for students. Suppose you have two pillows and three covers. How you are going, in what manner you are going to put the pillows in the cover. There are 6 manners. 6 ways, in 6 ways you can put them. So this is one example, simple example. Now genomics is another example which is mind-boggling. Finally, let us look at another example, state administration. Odisha state administration. Odisha, let us say 30 districts are there. To cover that, we have 3 RDCs and 20 CDMOs. Now, if you have to do a combination, permutation combination, how many possibilities are there? So that is mind-boggling. It is extremely difficult to do that. So we will not try that. Next. Now let us come to the examples. Second example, which is the same shloka. In this shloka, we start with a syllable. From the syllable, following the principle or the algorithm, we form words. From the words, by arranging the words, we get lines, and finally that gives rise to a poem. To get this, Pingala gave 6 combinatorial algorithms. One is called Prasthara that we have seen, then Sankhya, Adhyayoga, Lagakriya, Nashtam, Uditam. I will discuss about Prasthara we have discussed. I will discuss discuss one more, which is Lagakriya. That I will discuss later. So this is the fifth algorithm by Pingala, which is called Lagakriya. In the Chhandas Shashtra, you will see this Lagakriya. Now, let me explain this algorithm instead of reading through the shlokas. Let me explain this algorithm. Take a square box. Below that square box, put two more square boxes, so that half of the square box is on one box, another half is on the other box. Below that again put three boxes, so and half of that covers one box, half of that covers the other box, middle one is in between the rest half of the box. So that way you proceed to a number level. Now what you will do is, in the first cell, put 1. In the second cell, again put 1 and 1. In the third cell, at the two extreme ends, put 1, 1. And the middle one, for the middle cell, look at the upper cell above that cell. Whatever is the addition of those two cells, that will be there. So that will be 2. Go to the third cell. In the third cell again, last two cells will be always 1. Then come to the next cell. So these two cells, so that will be above that is 1 plus 2 is 3, 2 plus 1 is 3. So this way you keep on proceeding. Next. So if we go or proceed this way from starting from one cell to we are keeping on increasing these cells, this process is called Meru Prasthara. In those days, this process is called Meru Prasthara. By this time, Sausar, Manosar, uh, all these physical science people, engineering people, they would have known what is this, what we call this today. They would have known this, but I will not call that right now. I will call it Meru Prasthara for the time being, till we come to the next point. So this is Meru Prasthara, and this is depicted in the Mahameru Yantra that is available nowadays in the market, which says that the energy flows from one point to it spreads downward. So that is what is the Mahameru Yantra. So forget the Mahameru Yantra, but look at the Meru Prasthara. Next. Now, let me explain how the Meru Prasthara is used. This was the question. Savsar asked this question, whether they used these numbers. So this is the use of number. Suppose you have 6 coins. In how many ways we will get out of these 6 coins? If we toss these 6 coins, in how many ways we will get 2 tails? So that is explained using Meru Prasthara. In the old days, there was no computer, neither there was this permutation combination to find out how many ways you will get 2 tails. But using this Meru Prasthara or this algorithm, you will get this. So first one, let us call it row 0, R0. Second line is R1. So that way up to R6. 6 rows we have here. Why 6 rows? Because we have 6 coins. Number of coins is equal to number of rows. Now come to the 6th row. In the 6th row, the first box gives you 0 tails and 6 heads. That will be in one way. You will get second column is 6. So that says 1 tail and 5 heads in 6 ways. 2 tails, 4 heads in 15 ways. So look at the numbers. Those numbers say you in how many ways you will get a particular combination. If you have 6 coins, then there are 64 possibilities. But out of those 64 possibilities, in how many ways you will get a particular combination, that is given by this. So this is if you arrange this, the coins are arranged on the top right hand side. You can see the past from the left to right. If you move, the diagonal is all heads. On that square, the diagonals are all heads, others are tails, though indicating the 6 ways of how you will get a head and tails. So okay, that. Next. So basically this was used as a lookup table of numbers to determine combinations. Next. Now, let us see another application. Suppose you have one syllable. In how many ways you can get one guru and one lagu? That is one way. If you have two syllables, you will get it in how many ways you will get it. So that is again three ways. So that way, if you have syllables, you will get it in 15 ways. So 15, six syllables, 15 ways, five syllables, 10 ways, so, and then four syllables, 6 ways, three syllables, 3 ways, two syllables, one way, one syllable, again one way. Okay, this is how people used to construct the words using the Meru Prasthara. Next. Now, this we just discussed 2 to the power n gives all the possibilities, and Lagu Guru that we discussed. So I will not go into this. Now, this shows how they used 0, 1 or binary system and the number system to form the poems. So this is by an unknown Sanskrit poet around 755 CE. So in those eras, so around 755 CE means about 1,000 years before Leibniz. So they used these tables to construct these poems, and here you can see the numbers, ones and zeros. Next. Now there is modern days we have application of this Meru Prasthara. The binomial theorem or the binomial coefficients. Each row gives a binomial coefficient. Row 2 gives binomial coefficient for x plus y square. Row 4 for x plus y to the power 4. So binomial coefficients are also derived from this Meru Prasthara. Next. Then use this Meru Prasthara. From that table, lookup table, add the corners. If you add the corners, that will give us the Fibonacci series. So that was also, this was also shown by Pingala. 1, 1. If you add the corners, you will get 1, 1, 2, 3, 5, 8, 13. So you just search in Google. For the Meru Prasthara, you will find this. Tables you will find in the palm leaves, and written in palm leaves in much earlier than Leibniz. These they are given arrow marks and shown this. So this you will find a Fibonacci series. But the series is called Fibonacci series. There is no credit to Pingala. Next. Applications, I don't want to talk about the applications of Fibonacci series. It is found in nature, so I don't want to talk about this. Next. Then comes the series, Fibonacci series or history. This was first acknowledged by this Italian mathematician Fibonacci. He himself, in his write-up, Libere Abaki, he writes that this he got from the Indian method. You can see from his text, I have underlined the Indian method. He mentions that he has got this from the Indians. So Indian method he gives credit to. So Fibonacci himself gives the credit to the Indian methods, but it is called Fibonacci series, not the Pingala series. Next. Now let us see what this Meru Prasthara is called today. It started around 200 to 300 BCE by Pingala in India. Then Omar Khayyam in the 11th century, in Persia, Omar Khayyam, they got this from India during their trade with India. They got this. Then it went to China in the 13th century. Yang Hui, they developed in their way. They developed this Meru Prasthara. Then Niccolo Tartaglia, he developed this in 16th century in Italy, and Blaise Pascal in France, after Nicolas Tesla, Blaise Pascal, he developed it. And this is called the Pascal Triangle. Instead of giving the credit to Pingala, this is called the Pascal's Triangle. You must have, by this time you are known this. This table, the expansion is called Pascal's Triangle. Okay, next. So to sum up what we discussed, except what I had excluded, is how it developed. It developed from Shiva Sutras in the Vedic era. From the Shiva Sutras came the four Vedas, Rig Veda, Samveda, Yajurveda, Atharva Vedas. From the four Vedas came six Vedangas. Now these are Sikhya, Nirukta, Vyakarana, Kalpa, Jyotisha, and Chhandas. This Chhandas was in the Vedanga, which is Chhandas. This was developed by Pingala Acharya. Next. So, Chhandas by Pingala Acharya, he gave six combinatorial algorithms. The algorithms I have discussed. Next. Those were used by different scientists or different knowledgeable persons in different eras at different times, and they find they developed basically because of that we developed the binary system, algebra, combinatorics, infinity series, and others, which find applications in areas like electronic computing, statistical physics, genetic analysis, machine learning, etc. So, with that, we conclude about Chhandas Shastra. Then I will come to the cryptography. Cryptography comes from the word cryptos, which means something is hidden. The word cryptos is a Greek word which means something is hidden. By definition, this is construction and analysis of protocols hidden from third parties or public domain. They protect digital data because of this construction, and they transform data into formats which are unrecognizable without authorization, which means these are encrypted messages which replace letters with other characters. This is basically what is cryptography, what we know. So this is today, nowadays, in the modern era, this is used as a tool of secrecy. In the old Indian tradition, if you look at the old Indian tradition, in the old Indian tradition, knowledge was transmitted using the Guru Shishya Parampara. In the Guru Shishya Parampara, the Guru tells the Shishya, or Guru ensures that Shishya learns it and learns the knowledge. Knowledge is transmitted in a verbal manner from the Guru to the Shishya. In the old days, there was no writing. Very old days, there was no writing. After that came these palm leaves. Before that, there was no writing principle available in India. So everything, the knowledge in those days, they were transmitted in verbal manner. Now, for example, we had Susruta Samhita, which is on surgery, medicine. Similarly, these are the different principles, different compilations on different areas: astronomy, astrophysics, yoga, business administration, calculus, etc. Now, how was this possible? So there were three main techniques that were used to transmit the knowledge verbally. The first technique is rhythm. So this rhythm, the knowledge that is transmitted, is in the form of poems or Sanskrit shlokas, which are rhythmic as per Chhandas Shastra rule. Since they are rhythmic, as you know, when you listen to a music, it is easy to remember the music rather than reading it. So that was one of the main techniques. Then dialects. In the dialects, and the Guru used to have a discussion with the student, with the Shishya. So that can be in the form of a storytelling or in the form of a question answering. So that way also it is easy to remember if you listen to a story or if we listen to questions and answers. So then that gives you remembering capability increases. Then aphorism. Aphorism means if you have a large chunk of material to remember, put it in the form of a sutra, small sutra. So condense it. So optimal use of words to form a sutra. So remember the sutra instead of a large chunk. Remember a sutra which is short. So these were some of the techniques that was used in those days. Now we'll see what happens in these techniques. Look at this. This also I discussed in the last uh, lecture. Look at this. This is a Sanskrit verse. Maki, Vaki, Faki, Raki, in that way. Now, even if one knows Sanskrit, he will not be able to understand what is saying, what is said here. Because these are not, although these are Sanskrit words, they have no meanings. It gives no meaning to anybody else. Next. Now, let us see what that sloka means. So, in those days, this was proposed by Aryabhatta. He said, and why it was proposed? Aryabhatta, as you know, is a great astronomer of India. In astronomy, one has to deal with very large numbers, very large, extremely large numbers. Distance to sun, distance to any other star, those are very large. So one has to remember those numbers. And remembering such large number is extremely difficult. So what he did is he proposed a system of remembering numbers through alphabets. So those are called alpha syllabic number system. Nowadays that is called alpha syllabic number system. In those days, those are called akshara sankhya. So you have alphabets and then you map the alphabets to numbers. This is one example in which we map the numbers to numbers. O is mapped to 1, O is mapped to 9. So A is mapped to 2, O is mapped to 9, AO is mapped to 2 plus 9, which is 11. So instead of saying 11, if I say AO, it means 11, although AO does not mean anything. It actually means 11. Next. So Aryabhatta, he proposed this alpha syllabic number system, which is called Aryabhatta's alpha syllabic number system. In Odia, we call it Aryabhatta Akshar Sankhya Vyavastha. So in this, what he did is he assigned the vowels starting from O to OO, etc. as O is 10 to the power 0, I is 10 to the power 1. So in the form of decimal place values, 10 to the power 0, 10 to the power 1, 10 to the power 2. That way he arranged this. This is given in the second sloka of his Ganitapada. Aryabhatta, in the Aryabhatta, this sloka is given. It says this: vowels are to be written in this manner. Then consonants, each consonant will be assigned a number. So ka varga, ka, kha, ga, ga. So ka varga is ka is 1, kha is 2, ga is 3, ga is 4, ma is 5. So this way, ka chata tapa. So the numbers are 25. Then ja is 30, ra is 40, ra is 50, ba 60, dante sa 70, talave sa 80, murdane sa 90, ha is 100. So these are the numbers assigned to the syllables. Now once you use these numbers in the syllable, then we'll form how, now we can see how this helps in remembering large numbers. Now suppose Pucci. Pucci is the word that has been formed, that we are writing Pucci. Now Pucci has Pa plus U. Pa is 21. Look at the table. Pa is 21. U is 10,000. So Pu is 21, 2,10,000. Now Cha, Chi means Cha. Cha is 6. E is 100. So Cha plus E is, and Cha into E is 600. So 2,10,000 plus 600. Pucci is 2,10,000 plus 600. So 2,10,600. Instead of remembering this large number, if I say Pucci, I remember this. It is easier. Pucci is much more easier than 2,10,600. So as these numbers keep on increasing, we will see one example now. The same thing, Bucha is 30,007. Getchi. So now you can see exponential, these are increasing. Bucha, Getchi, Gochi, Gochi. So you can see the numbers increase, the value of numbers increase exponentially. It is difficult to remember them, but if you remember these alphabets, so alphabetically you form a word, remember that word. And in the using those words, then use the Chhandas Shastra to form a poem. So first you create the words, then form a poem, then it is easy to remember the poem. So from the poem you can extract. Next. Now let us look at this, the Aryabhatta first one, which I told you. Makhi, Vaki, Faki, Daki. So those are the numbers 255, 224. These are the numbers they represent. So if you remember this, then you remember all these numbers. Now what are these numbers? These numbers are R sign differences in terms of minutes of R. R sign means R is the radius into the sign of alpha. So take a circle, based on move on the circle, one complete rotation in the circle gives you a complete sine wave. So circle radius is R. Then when you are moving in steps, so those steps gives you the difference. So that is how you get this R into sine differences in terms of minutes of work. Arc. Next. So if you plot them, that gives you a sine wave. So these look like a bow. The sine wave looks like a bow. Therefore, Aryabhatta gave it the name Jya. Jya means bow. Jya in Sanskrit means bow. This was distorted in Persian. They got it and they gave it Shiva, Jiva, or they call it Shiva. So that again went to Latin, it got distorted, it becomes sinum. From sinum in English, it becomes sine. So now you get the sine, which was originally, this table was given by Aryabhatta. Next. This is actually acknowledged by British people in the British Raj in the India. They have acknowledged that Aryabhatta had a system of remembering numbers using this alphanumeric system, alpha syllabic system. So that was the British research was that. So you can see this Maki Waki is within the box, and they mention Hugri. I will show you what is Hugri for the revolution of the sun. So let us see. So now sun is revolving around its own axis. So it is spinning around its own axis. In one yuga, this is the Shloka says, the third Shloka of Gitika Pada in Aryabhatta, it says Jugara Vibhagana Bhrugyu, which means in one yuga, how many times the sun is rotating around its axis. So revolution of sun around its own axis in every cycle of yuga. And that takes how much time? Q group. Q group, if you put it in this format, Akhyar Vyavastha format, Q group means 4,32,000 times. So in one yuga was in those days time was measured in Nimisaw, Jugo was the largest one. So Nimisaw is the smallest one to Yugo. So in the Yugo, one Yugo, it is 4,32,000 times. It revolves around its own, or it spins around its own axis. That was, as an astronomer, Aryabhatta gave this. Next. Similarly, about 1000 years, around 1000 years after Aryabhatta, another alpha syllabic number system came, which is called the Kattapayadi number system. So in this, all consonants, they represent different integers, while vowels represent zero. Its working is similar to Aryabhatta system. Instead of reading this shloka, I will give you one example. Next. So this is a poem written by Melapathuru Narayana Bhattari in the praise of, as a uh, verse which is called Narayaniam, in the praise of Narayana. He ends this saying this has 100 shlokas. The last shloka, the last word is Ayurarogya Sokhyam. What means Ayu? Arogya Sokhya. So if you read this 100 shlokas, then you will be blessed with, this means, then you will be blessed with Ayu, you will be blessed with Arogya, and you will be blessed with Sukha, Sokhya. So these are the three things that you'll be blessed with if you read this. So this gives you, so if you look at it superficially, this gives you this meaning. But wait here, the Ayurarogya Sokhyam in Kattapayadi alpha syllabic number is actually 17,12,221. What does this mean? This means that he gave his signature, Vattathiri gave his signature here, saying that he completed this poem on the 17th lakh 12,211 day of the Kali Yuga, which is represented by this Ayurarogya Sakhyam. Now, if you divide it by 365 and take into account the leap years, that says that this is the year 1587, month November 27th day. So on that day, this was completed. So this is how people used to camouflage their what they wanted to say in those days, and it was easy to remember. It was not, those were not to hide anything, it was easy to remember. Now, we have come to the end of my discussion, and since it is about the Bharat, what is Bharata without Krishna? Mahabharata is from by Krishna. So what is Bharata without Krishna? So I will end it with a prayer for Krishna. This prayer means, O Krishna, the fortune of gopis, the destroyer of demon Madhu, the protector of cattle, the one who ventured the ocean depths, destroyer of evildoers, one with plough on the shoulder and the bearer of nectar, may you protect us. So with this shloka to Lord Krishna, let us end here. But wait a minute, just a minute. What is the icing on the cake in this shloka? If you use again this Katipayadi, this shloka means last part of the shloka or this shloka itself. So this means using Katipayadi 3.14159, 26535, 89793, 23846, 26433, 832792. And I think this has ringed a bell. What is this? This is the value of pi. So this shloka is in the praise of Krishna, but it contains the value of pi, which is correct up to 30 decimal points. Only change is 2. If you Google in the Google, you will find this 2, the last number should be 5. So today with computers we found 5. In those days it was correct up before that point. So they found this. This was used in the astronomical calculations. So with that, I'll come to say that uh, we used in India cryptic number systems like Aryabhatta Akhyara Sankhya, Kattapayadi Akhyara Sankhya, Bararuchi Akhyara Sankhya, Akhyarapali Sankhya, Bhuta Sankhya, etc. So there are many, a list goes on. And we never use this to hide anything, but to carry knowledge flow of, to maintain the flow of knowledge with this knowledge. So let me thank or let me express my gratitude to different sources like Google, YouTube, Project Shiva Home, from which I gathered this information. And finally, I thank you all for being present here and for your patience hearing to what I wanted to tell. Thank you.
Hmm. Thank you, Mr. Sir, for this wonderful talk. Sort of, you really gave us a, though it's not a secret, but many of us probably we didn't know the background of all that led to the modern day number system and how it is being used in computer science, cryptography, and various other applications that you discussed. In fact, I never knew that this Fibonacci number series, and of course, I knew that Aryabhatta has contributed to zero, but I never knew the Fibonacci and series and all that. It has a background like this. But now I just wonder whether the Indian mathematical community and other people, whether they have raised a claim like we had a